Okay, now we can talk about section 6.4, implicit differentiation. So in order to do implicit differentiation, everything that we've been talking about so far has been a function of x. In other words, we've been having explicit functions, meaning everything can be solved for y equals. So in other words, we've been in the cases that look like these right here. Y equals x squared plus 1, y equals the square root of x cubed minus 17. Everything has already been nicely done for us. Now we're going to move into what we call as implicit functions. And what we mean by implicit functions is these functions are not defined where we can always solve for y equals. So examples of these are like x squared plus y squared equals 4. Xy minus 4y equals xy squared plus 2. X over y cubed plus 5y equals 2x minus 1. So in most of these cases, there's no way we could solve for y because one, there's either too many y's in there, or two, if we solve, we would have to create a square root, which means we would have plus or minus that value. So that's why we have what is called implicit differentiation. It's a way to find a derivative for implicit functions. It's nothing more than a special case of the chain rule. And that's really what it is. So in other words, for implicit differentiation, all of our rules of finding derivatives are going to stay the same. So for a function containing x and y, we want to differentiate every single term with respect to x. Keep in mind that y is equal to f of x right here. In this case, f of x is unknown, meaning we know that it is a function of x, we just don't know what it is. So every time that we take the derivative of y, we have to include the term dy dx beside it on that side. Next, we're going to get all the sides everything that has a dy dx on one side, we're going to factor it out, and we're going to solve for dy dx. Dy dx has many meanings, and we've been using dy dx just as our derivative because remember, dy dx is the same as y prime or the same as f prime. They all represent the same thing. It's still a derivative. It's still going to be the slope of our tangent line if we plug in a point. It's still going to give us a slope. It's all just dependent on what we're looking for. What we learn early on here, we might find a different way later on to be able to do this depending on our knowledge of things. So let's look at some examples here. So x cubed plus 2y to the fourth equals 7. So the derivative of x cubed is 3x squared. The derivative of 2y to the fourth is 8y to the third times dy dx, because y is a function of x. So therefore, we don't know what it is. We got to put dy dx. Derivative of 7 is 0. So we only have one term that has dy dx in it. So we're going to keep it on one side. So 8y cubed dy dx equals minus 3x squared. Therefore, solving for dy dx equals minus 3x squared over 8y cubed. So this would be our derivative here. Very similar problem here. 2x squared equals 4y cubed plus 9. So the derivative of 2x squared is 4x. That's going to equal the derivative of 4y cubed is 12y squared dy dx. Plus 9's derivative is 0, so we don't have to write it. So solving, we get dy dx equals 4x over 12y squared. We could simplify this to x over 3y squared is equal to our dy dx. To simplify that, always make sure you simplify because it'll make it easier whenever we start having to plug in values. So just like before when we took derivatives, simplify as much as we can. So here's a slightly different style one here. Now, since y is a function of x, this first term here of xy is a product rule. So the derivative of x is 1 times y plus x times the derivative of y is 1 dy dx plus y cubed's derivative is 3y squared dy dx equals 0. So now here's our first case where we have more than one dy dx. So I'm going to keep every term that has dy dx in it on one side. So I have x dy dx plus 3y squared dy dx. On one side, I'm going to subtract over the 1y, so minus y goes on the other. The next thing our stuff told us to do was to factor out dy dx. So dy dx times x plus 3y squared equals minus y. Solving for dy dx, we get minus y divided by x plus 3y squared. So even if we have more than one term of y, only thing we got to worry about is if we have a product rule like we did in this case of x times y, and then we can just simply work it just like before. A little bit more complicated looking one, but it's still going to give us the exact same style. So we have a product rule here. Derivative e to the x is e to the x times our natural log of y plus e to the x times the derivative of ln of y is 1 over y times dy dx equals 4 dy dx when we took the derivative of 4y from the other side. Now, I don't want to have to worry about fractions. So what I'm going to do is I'm going to get rid of that fraction of 1 over y by multiplying everything by y. So I'm going to get y e to the x ln of y plus e to the x dy dx equals 4y dy dx. Next, I want to get everything with the dy dx on one side, everything else on the other. So y e to the x ln y equals 4y dy dx minus e to the x dy dx. Factoring out my dy dx, we're left with 4y minus e to the x, and that's all equal to y e to the x ln y. So solving for dy dx, we get y e to the x ln y over 4y minus e to the x is equal to dy over dx as our final answer here. So these haven't been that bad in terms of what we've had to do, but it's getting us used to this new process that we're going to do. Now these next ones, I went ahead and put the answers right below it. So I'm going to work these out to the side here. So given x squared y cubed equals 8, we want to find the equation of our tangent line. So I'm not even going to worry about the equation until after I find dy dx. So we have a product rule of 2x y cubed plus 3x squared y squared dy dx equals 0. Solving for dy dx, we get 3x squared y squared dy dx equals minus 2xy cubed. So dy dx is equal to minus 2xy cubed over 3x squared y squared. And if we simplify this, we get minus 2y over 3x as our dy dx. Now, we then need to come back over here and plug in at the point 1, -2, or negative 1, 2, sorry. So we're at the point -1, 2. So -2 times 2 over 3 times -1 gives us -4 over -3, or 4/3. So that is our slope. So this equals dy over dx, also known as our slope of our tangent line. So we have a point, we have a slope, we're going to put it in the form. So y minus 2 equals 4 over 3 times x plus 1. Y equals 4/3 x plus 4/3 plus 2. So y equals 4/3 x plus 10/3. So this would be the equation of our tangent line, which should match the answer that I gave you right here. So they do match. That's a good thing. It means I didn't make any mistakes whenever I was writing out those solutions. All right, this one's a little bit more complicated as you can see down there for the answer for dy dx. So we have y ln x plus 2 equals x to the 3 halves y to the 5 halves. So we need to find its derivative. So product rule, so we have ln of x times dy dx plus y over x equals 3 halves x to the 1 half y to the 5 halves plus x to the 3 halves times 5 over 2 y to the 3 halves dy dx. I don't want to work with any of these fractions here. So what I'm going to do is I'm going to multiply everything by a fraction of 2x, because I have this x right here and I have a 2 in my denominators in the other spots. So when we do that, I get 2x ln x dy dx plus y equals, or plus 2y, sorry, plus 2y equals 3x to the 3 halves y to the 5 halves plus x to the 5 halves would be, actually, sorry, 5x to the 5 halves y to the 3 halves dy dx. I need everything with the dy dx on one side, everything else on the other. So 2x ln x dy dx minus 5x to the 5 halves y to the 3 halves dy dx equals 3x to the 3 halves y to the 5 halves minus 2y. I'm going to factor out my dy dx. So we have 2x ln x minus 5x to the 5 halves y to the 3 halves equals 3x to the 3 halves y to the 5 halves minus 2y. So dy dx equals 3x to the 3 halves y to the 5 halves minus 2y over 2x ln x minus 5x to the 5 halves y to the 3 halves. So this would be my dy dx. Hopefully It matches. Two ln x minus 5x to 3/2. So that one does. My derivative yeah, that's not correct. That's incorrect in our derivative over there. All right. So now we're going to work out x squared e to the y plus y equals x cubed. That one in the previous one forgot one of the key pieces and everything in terms of our product rules. Hopefully that's the only mistake on these. So for this type of problem, we can see different things here to be able to see what is our derivative in this case. All right, so taking this derivative here, we have a product rule here. So this is going to be 2x e to the y plus x squared e to the y dy dx plus the derivative of y is dy dx equals 3x squared. So getting everything with dy dx on one side. X squared e to the y dy dx plus dy dx equals 3x squared minus 2x e to the y. Now, when we factor out this dy dx, do not forget that when you factor it out of itself right here, that you have a plus 1 that needs to be written down. We don't want to make a little simple mistake here that's going to cost us the problem. So in this case, dy dx equals 3x squared minus 2x e to the y over x squared e to the y plus 1 would be our dy dx. Good, I didn't make a mistake on that one. All right, so now we're back to finding the equation of our tangent line. So 2y squared minus the square root of x equals 4. We're going to be at the point 16.2. So let's see what we can do here. 4y dy dx minus 1 over 2 root x equals 0. So 4y dy dx equals 1 over 2 root x. So dy over dx equals 1 over 8y square root of x. We need to plug in at the point 16.2. So we have 1 over 8 times 2 times the square root of 16 gives us 1 over 16 times 4, which is 1 over 64. So this is our slope. We wanted the equation of our tangent line. So it's going to be y minus 2 equals 1 over 64 times x minus 16. Y equals 1 over 64. X minus 16 over 64 is 1/4 plus 2. So we get y equals 1 over 64x plus 7 over 4. Which is exactly what we have over here. So the next one we can have is x squared plus y squared equals 25. This is at the point negative 3, 4. So 2x plus 2y dy dx equals 0. 2y dy over dx equals minus 2x. dy over dx equals minus x over y. This is at the point negative 3, 4. So negative of negative 3 over 4 gives us 3/4 as our slope. So then we have y minus 4 equals 3 over 4 times x plus 3. Y equals 3/4 x plus 9 over 4 plus 4. So y equals 3/4 x plus 25 over 4 as the equation of our tangent line. If you wanted to write this in terms of, this is written in just slope-intercept form, we could write this in terms of standard form, depending on what it's asking for in the problem. So this is slope-intercept. If we wanted to go to standard form, we need to get rid of all fractions. So 4y equals 3x plus 25. We need our x to be positive. So this is going to be 3x minus 4y equals negative 25. This would give us standard form. So it all just depends on what the problem is asking. This one didn't state it, but it looks like I wrote it in standard form. So that means most likely a problem in your homework is probably going to ask for something like that. So just remember, anytime that you are taking the derivative that has an x and a y in it, that's multiplied, you got to think product rule. Be careful with everything. You can make mistakes. If you notice, like I said, way back up here on the problem that I crossed out, if you look at some stuff, you'll see that I forgot about a y over x term. So, if you forget a term, it's going to throw it off. In this case, this is the correct answer. The other one is missing a y term. So keep that in mind.